Good morning, one and all. My name is T. Rajita, lecturer in ACE, Government Polytechnic, Mavnar. So I am dealing with third semester and I am taking network analysis subject. Now I am going to discuss the topic, the mesh current equations of network and arranging the mesh equations into matrix form. So in the last class, we discussed about the number of mesh equations, that is identification of mesh equations. So in that, first we check the planarity of circuit. The circuit is said to be planar if it can be drawn on a plane surface without crossover. So if it is not there, if it is not planar, first the circuit must be drawn into a planar circuit. Then second thing is selecting the mesh currents. So the number of mesh equations required to solve the given network is, if there are B branches and N nodes in a network, then the number of mesh current equations are given by M is equal to B minus N minus 1. This is the equation. So from this equation, we are identifying the mesh equation, mesh currents, and then we have to write the mesh equations. So in this class, I am going to explain how to write the mesh equations and it put into a matrix form. So before that, in the last class, we identified the mesh currents. Now I am going to write the mesh equations. So on completion of this period, you would able to find out, you able to write the mesh current equations for a given network and arrange them into a matrix form. So consider a general network. This is the network. So here we are taking 3 mesh currents. See, in this circuit, the number of branches are 5 branches are there and 3 nodes are there. So 5 minus 3 plus 1 is equal to 3 mesh equations. So 3 mesh currents are there. So here the 3 mesh currents for identifying such that mesh 1 I1, mesh 2 I2 and mesh 3 I3. Like that, here we are identifying the meshes. So from the formula, we are identified the 3 meshes, mesh 1, mesh 2 and mesh 3, and the currents are I1, I2, I3. See, this is the circuit. Now from this, I am going to write the mesh equation 1 for current I1. Just to consider the first mesh 1, here the current is flowing from E1 to ZA and E to ZB. So here you have to consider the direction, and E1, E2 are in the same direction. See here, E1 is direction is different and E2 is opposite direction in that mesh equation. So here ZA plus ZB into I1 minus ZB into I2 is equal to E1 minus E2. How it is getting? See, in ZA, the current I1 is flowing. In ZB, the current I1 minus I2 is flowing. In the ZB, the current I1 and the current I2 flowing in opposite direction. So for mesh 1 equation, we are considering that applying a Kirchhoff's voltage law, the mesh 1 is a closed loop and the voltages, algebraic sum of all the voltages is equal to 0. So the voltage across ZA is I1 ZA and voltage across ZB is I1 minus I2 into ZB. So by adding all these, E1 minus I2 is equal to ZA into I1 plus ZB into I1 minus I2. So by rewriting that equation, we are getting that ZA plus ZB into I1 minus ZB into I2 is equal to E1 minus E2. This is the first equation. Similarly, for mesh 2 equation, in this, the current flowing ZB, by considering mesh 2 equation, the current flowing in ZB is I2 minus I1. And in ZC, current is only I2. But in Z2, the current is I2 minus I3. So by taking that, minus ZB into I2 minus I1 plus ZB plus ZC plus ZD into I2 minus ZD minus I3. How it is this equation 2 is getting means, the current, the algebraic sum of all voltages in mesh 2 is equal to 0. So here the voltage and currents E2 and the current I2, by considering this, we are adding all the voltages in the circuit is equal to 0. Here the voltage across ZB is I2 minus I1 into ZB. The voltage across ZC is I2 into ZC. The voltage across ZD is I2 minus I3 into ZD. So by adding this, I2 minus I1 into ZB plus I2 minus I3 into ZD plus I2 into ZC plus E2 is equal to 0. So by taking this in an arranged form, what we are getting this minus ZB into I1 plus ZB plus ZC plus ZD into I2 minus ZD into I3 is equal to minus is plus 2. Now the third equation here, it is I3. So in this, the current flowing through the ZD and E3 direction is in opposite direction. See here, by writing this equation, the current flowing through ZD is I3 minus I2 and ZE is I3 and voltage source. So here ZD into I3 minus I2 plus ZE into I3 is equal to minus E3. So by rewriting this, 0 into I1 minus ZD into I2 plus ZD plus ZE into I3 is equal to minus I3. These are the three equations, mesh current equations. In matrix form, we can write the same three equations in a matrix form like this. See here, ZA plus ZB minus ZB and 0 is the first equation quotients, and second equation coefficients is minus ZB, ZB plus ZC plus ZA and minus ZD, and third equation coefficients 0, minus ZD, ZA plus ZD into this matrix into I1, I2, I3 is equal to, and voltage matrix E1 minus E2, E2 minus E3. Then in this way we have to write the mesh equations, and we are writing into a matrix form. That is Z matrix into I matrix is equal to the voltage map. According to Ohm's law, V is equal to I into Z. So this is the impedance matrix ZA plus ZB and minus ZB 0, minus ZB, ZB plus ZC plus ZA minus ZB and 0, minus ZD and ZD plus ZE is the impedance matrix, the equation. So current I is equal to I1, current matrix is I1, I2, I3, and voltage matrix is E1 minus E2, E2 minus E3. This is the voltage matrix. So from the equations we can write into a matrix form, that is impedance matrix, current matrix and voltage matrix. In this way we are going to write the mesh equations in a matrix. So first thing, the circuit must be identified the meshes, mesh currents. And so once you are identified the mesh currents, mesh loops, then we can write the equations. So by considering individually each mesh, and we have to apply the Kirchhoff's voltage law, and we have to write the equations. So the above matrix form of mesh equations can also be written in simple inspection. So the general form of mesh equations for any three mesh network is Z11 I1 plus Z12 I2 plus Z13 I3 is equal to V1, V11. Z21 I1 plus Z22 I2 plus Z23 I3 is equal to V2. In this way we can write that what is Z11? Z11 is the input impedance, Z12 is the transfer impedance from mesh 1 to mesh 2, and Z13 is the transfer impedance from mesh 1 to mesh 3, and V11 is the voltage that is appeared in the mesh 1. And Z21 is the transfer impedance from mesh 2 to mesh 1, and Z22 is the impedance in mesh 1, mesh 2, and Z23 is the transfer impedance from mesh 2 to mesh 3, and V22 is the impedance that is appeared in the mesh 2. And third equation is Z31 I1 plus Z32 I2 plus Z33 I3 is equal to V3. Z31 is nothing but the transfer impedance between mesh 1 and mesh 3 into I1, and Z32 is the transfer impedance between mesh 2 and mesh 3 into I2, and Z33 is the impedance in Z3, and that is equal to V33, that is the voltage appeared in mesh 3. So now in matrix form, Z11 and Z12, Z13 and Z21, Z22, Z23 and Z31, Z32, Z33. We can write the quotients, and current matrix is equal to voltage matrix. That is impedance matrix into current matrix is equal to the voltage matrix. That is Z into I is equal to V, where impedance matrix is The Z11, Z12, Z13 is the first mesh equation coefficients, and Z21, Z22, Z23 is the second mesh 2 coefficients, and Z31, Z32, Z33 are the third mesh equation coefficients. So these are the impedance matrix. The left subscript attached to each element indicates the row it occupies, and the right subscript attached to each element indicates the column it occupies. See again, I am telling that the left subscript attached to each element indicates the row, and right subscript attached to it indicates the column. So the diagonal elements Z11 indicates self-impedance of the mesh 1, Z22 indicates the self-impedance of the mesh 2, and Z33 indicates the self-impedance of mesh 3. And Z12 and Z21 and Z13 and Z31 and Z23 and Z32 are the transfer impedances of the mesh. See here, Z1 and Z21 are the transfer impedance or mutual impedance of mesh 1 and mesh 2. And the sign of these two impedances depends upon the current flowing in both the meshes or in same direction. The positive sign depends the current or mesh 1, I1 and I2 are in the same direction in that branch, then the sign is positive. If the current flowing in that element is opposite direction, that is mesh 1 current and mesh 2 current flowing in that element is in opposite direction, then the sign of the transfer impedance Z12 or Z21, whatever it will be, it is negative. So the sign depends upon the flow of currents. So here Z23 and Z32 is the transfer impedances between mesh 2 and mesh 3. And the sign is always depends upon the current flowing I2 and I3 in the common element, circuit element between mesh 2 and mesh 3. And the current direction is in same direction, the transfer impedance is positive, and the current direction is negative when both the currents are in opposite direction, then the transfer impedance is negative. Similarly, in the Z31 and Z13. Z31 and Z13 are the transfer impedance between or mutual impedance between mesh 1 and mesh 3. And here the direction depending upon the current flowing in the common element between mesh 1 and mesh 3 depends the transfer impedance is negative or positive. See here, the sign is positive if current flowing in both meshes are in same direction. If the sign is negative, if current flowing in both meshes are in opposite direction, then it is the transfer impedance is negative. These are the rules in the mesh current equations. By directly we can write the equation. See from this, in mesh 2, I2 is passing through Z3 and Z4. I2 is passing through ZB and ZD. I2 minus I1 is passing through ZB. I2 minus I1 is passing through ZB. And KVL for mesh 2 is I2 into Z3 plus Z4 plus I2 minus into Z2. The equations are rearranged. Z1 plus Z2 into I1 minus Z2 I2 is V1. That is the first equation for first mesh. In matrix form, they can be arranged as Z1 plus Z2 minus Z2 so Z is impedance matrix. For example 1, example 2. Here it is identified as 3 mesh equations, mesh 1, mesh 2 and mesh 3. In this, we can write the first mesh equation is Z1 plus Z2 into I1 minus Z2 into I2 is equal to V1, because the current and I1 and I2 are flowing in opposite direction, and Z1 plus Z2 into I1 minus Z2 into I2 is equal to V1. This is the first equation. And in second mesh equation, minus Z2 I1 plus Z2 plus Z3 plus Z4 into I2 minus Z4 into I3 is equal to 0. This is the second mesh equation. And the third mesh equation is minus Z4 into I2, and there is no connection between mesh 1 and mesh 2, so that the first term is equal to 0, that is I1 mesh current is 0, and second one minus Z4 into I2 plus Z4 plus Z5 plus Z6 into I3 is equal to 0. These are the 3 mesh equations. Now we can write for this example. So in the matrix form, we can write that the first row of this matrix is Z1 plus Z2 minus Z2 0. And in the second mesh equation, we can write as a second row in the matrix minus Z2, Z2 plus Z3 plus Z4 minus Z4. And third row is 0 minus Z4, Z4 plus Z5 plus Z6 into I1, I2, I3 is equal to V1, 0, 0. In this way, we can write the mesh equations in a matrix form. So Z is the impedance matrix, I is the current matrix, and V is the voltage matrix. So after writing the equations, we are putting into the matrix form. From that, by applying some Cramer's rule, we can find out the currents that is flowing in I1, I2, I3. We can find out, from that we can find out the each current in each element also. So now I am explaining about example 3. So in this example, write the mesh current equations for the network given below. So it's a simple network. In this, 2 voltage sources are there, 16 volts and 18 volts, and both are in same direction. And here 3 branches and 2 nodes. So the total number of meshes identified here is 3 minus 2 plus 1, that is 2 mesh equations. And in these 2 equations, just I1 and I2. We are taking that the two mesh currents is I1 and I2. So we identify two meshes, that is mesh 1 and mesh 2, and the two mesh currents I1 and I2. So assume clockwise currents, that is I1 and I2, and we can assume that the current direction, it's not a depends upon our assumption only. We can take it any direction, that's not a problem. So in mesh 1, the current I1 flowing in 2 ohms resistor and in 4 ohms resistor, the current is I1 and I2 both are flowing but in opposite direction. See that in mesh 1, the current flowing in 2 ohms is I1 and the current flowing in 4 ohms resistor is, both the currents are flowing but is in opposite direction. So the KVL for mesh 1 is 2I1 plus 4 into I1 minus I2 minus 16 is equal to 0. 16 is the voltage applied to that circuit. So the KVL is the algebraic sum of all the voltages in the closed loop is equal to 0. So by applying mesh 1, 2 into I1 plus 4 into I1 minus I2 minus 16 is equal to 0. This is the first mesh equation. And in mesh 2 equation, the current I2 is flowing in 6 ohm resistor and in 4 ohms there is a current I2 and I1 both currents are flowing and the both currents are out of phase, that is opposite direction. So we have to take the direction in mesh 2 I2 minus I1. So that by applying the Kirchhoff's voltage law for mesh 2, the total algebraic sum of all voltages in the mesh 2 is 0. So from this we can write it 6I2 plus 4I2 minus I1 plus 18 is equal to 0. See here in mesh 1, the current is in opposite direction. Voltage source current and this current I1 is opposite. But here in the same direction. So 6I2 plus 4I2 minus I1 plus 18 is equal to 0. So after simplification, we can rearrange the mesh 1 equation and mesh 2 equations. Both the equations are 6I1 minus 4I2 is equal to 16, that is mesh equation 1. And minus 4I1 plus 10I2 is equal to minus 18. This is mesh equation 2. So these two mesh equations can be we can write in matrix form. So the two equations we can arrange it in a matrix form. There is 6 minus 4 and minus 4 10 into I1 and I2 is equal to 16 minus 18. This is the voltage matrix. So the impedance matrix is 6 minus 4 and 10 is the impedance matrix. The current matrix is I1 and I2. The voltage matrix is 16 and minus 18. See here, impedance matrix, current matrix and voltage matrix. In this way, we can write the mesh equations into a matrix form. So consider another example now. See, in this problem, how many branches are there? How many nodes are there? See, 6 branches are there, 4 nodes are there. 6 minus 4 plus 1 is equal to 3 is the equations. 6 branches, 4 nodes, and the number of mesh equations is 3. So we identified 3 meshes, mesh 1, mesh 2, mesh 3. So the direction is depending upon our assumptions. We are taken as the direction I1, I2, I3 that is shown in the figure. So now we can write the 3 equations, mesh 1, mesh 2, mesh 3. So by applying KVL to the mesh 1, we can write that 3I1 minus I2, 1 into I1 minus I2 plus 2 into I1 minus I3 is equal to 7 minus 6 volts. So from this we can rewrite, that is 3I1 minus I2 minus 2I3 is equal to 1. This is the first equation. See, again I am explaining the mesh 1 equation. The current in 1 ohm is I1 minus I2 and the current in 2 ohms is I1 minus I3. So that 7 minus 6 is equal to I1 into 1 ohm, I1 minus I2 into 1 ohm plus I1 minus I3 into 2 ohms. So that by rearranging this equation, we are getting that 3I1 minus I2 minus 2I3 is equal to 1. Similarly, the KVL equation for mesh 2 equation, in this there is no voltage source. By applying this, we can write the equation. In 1 ohm, there is a current is I2 minus I1. In 2 ohms, only I2 current is flowing. And in 3 ohms, the current is I2 minus I3, both are in opposite direction. So we can write in the second mesh equation, that is 1 into I2 minus I1 plus 2I2 plus 3 into I2 minus I3 is equal to 0. By rearranging this equation, we can write that minus I1 plus 6I2 minus 3I3 is equal to 0. This is the second mesh equation. And the third equation is, here one voltage source is there and in current in 2 ohms there is a two currents are there in opposite direction, that is I1 and I3, and in 3 ohms there is a 2 currents, that is I2 and I3. In 1 ohm only one current, that is I3. So in 2 into I3 minus I1 plus 3 into I3 minus I2 plus 1 ohm into I3 is equal to 6 volts. So by rearranging this equation into minus 2I1 minus 3I2 plus 6I3 is equal to 6 volts. These are the 3 voltage equations, mesh equations for this circuit. So we can write this equation by seeing this from this equation. We can write the matrix form 3 minus 1 minus 2, and from second equation minus 1 6 minus 3, and third equation minus 2 minus 3 and 6 into I1 I2 I3 is equal to 106. The first Z impedance matrix into current matrix is equal to voltage matrix. See where the impedance matrix is equal to 3 minus 1 minus 2 minus 1 6 minus 3 minus 2 minus 3 6. The current matrix is I1, I2, I3 and voltage matrix is 106. And I am taking another example, mesh current equation. Write the mesh current equations for the given circuit. Here, how many branches are there? Current sources A and B. (18 ohms) and 12 at an angle of 60 degrees. That is the current source. So converted into equal voltage source. See here, for writing mesh equations, we have to convert all the current sources into voltage sources. Here there is a current source, one voltage source and one current source. So the first step is we have to convert the current source into the voltage source. This 12 at an angle of minus 60 amps current source is in parallel with 18 ohms. That will be converted into a voltage source in series with 18 ohms. That is 18 into 12 at an angle of 60. That is 216 volts at an angle of minus 60 volts. Voltage source is in series with 18 ohms. Now the circuit is modified as 300 volts 3 is applied in first mesh and in second mesh 216 at an angle of minus 60. In this there is 3 branches, 2 nodes. The number of equations is 2 equations. We are selecting that because 3 minus 2 plus 1, that is a 2 equations, mesh equations, and we identify I1 and I2 are the meshes and the directions is also we are shown. So now we can write these 2 mesh equations is by applying a mesh equation. First one is 50, that is 30 into I1 plus 20 into I1 minus I2 is equal to 300 at an angle of 0. So by rearranging this, we can write that 50 I1 minus 20 I2 is equal to 300 at an angle of 0. And in mesh 2, the current in J15 plus 18 ohms, 18 plus J15 is I2 and in current in 20 ohms is I2 minus I1. So 20 into I2 minus I1 plus 18 plus J15 into I2 is equal to 216 at an angle of 60. By rearranging this, we can get that is minus 20 I1 plus 38 plus J15 into I2 is equal to 216 minus 60 degrees. This is the second voltage equation. So this we can write in a matrix form. See here, that is 50 minus 20 minus 20, 38 plus J15 into I1, I2 is equal to 300 at an angle of 0, 216 at an angle of minus 60 degrees. So in this the impedance matrix is 50 minus 20 and minus 20, 38 plus J15 is the impedance matrix. Current matrix is I1 and I2 and voltage matrix is 300 at an angle of 0 and 260 at an angle of minus 60 degrees. This is about the fifth example. We can write the mesh equations and we are putting into the matrix form. So till now we discussed about the mesh equations. We discussed writing the mesh current equations for a given network and arranging the mesh current equations in matrix form. So take the assignment. Write the mesh current equations for a given network and arrange them into the matrix form. Here also we have to write the current source convert the current source into a voltage source and write the mesh equations. Here we are getting only two mesh equations and we can write. So the frequently asked questions, it may be write a mesh equations and arrange into a matrix form for a different types of circuits. For example, this is one circuit and this is another circuit. In this circuit, three meshes are identified and we have to write in a matrix form. These I1, I2, I3 are the mesh equations, mesh currents, and in 3 ohms there is I1 and I2, both currents are there and these are oppositely flowing, and in J6 it is I2 and I3 are there and these two currents are oppositely flowing. So the three mesh currents will be, mesh equations can be right and it can be put into a matrix form. In this third also we are getting a three mesh equations because three closed loops are there, and in this at 10 ohms there is a two currents are flowing. In 5 ohms mesh 1 and 3 is flowing out of phase, and in 10 ohms I1 and I2 both are out of phase is flowing. In 3 ohms I2 and I3 both are out of phase. So here the three mesh equations we get it and we can write into a form. Here in this circuit only two mesh equations are there, and in 5 plus J20 both are, the I1 and I2 are oppositely flowing and only two mesh equations can be